after having understood the concept of partitions and equivalence classes which are generated by equivalence relation, now let me give you few examples. So in certain cases, when we wanted to partition some group G, right, this is our group G, and when we wanted to partition this group G into different equivalence classes, so what we do, we define the subgroup H in that manner such that we have a partition in the desirable manner. For example, suppose our group is the group three-dimensional space, right, R cube. So this is our group, and now what we do, we select the subgroup H as the group which is a plane which passes through origin. It could be any plane. So all the plane which passes through origin are the member of this H, right? And this forms our subgroup here. Now here the group operation that we are taking it, we are component wise adding. So we are taking some point in three-dimensional space. So let's call that point as x, y, z. So suppose one point is this, another point is x2, y2 and z2. So therefore our group operation defines that we have x1 plus x2, y1 plus y2 and z1 plus z2. So this is our group operation. Okay, now what we do, we take some point ABC and we call this to be the coset representative here. For this coset representative, we can define a coset, because here the operation is component wise addition. So we have the form of our coset like this, the point plus the given subgroup, right? So this is our coset, and now this coset, what does it represent? It represents a plane which passes through this point ABC and it is parallel to the given plane of subgroup H, correct? So this is our coset. So that means different coset would give us different planes which passes through the points which are used to create the cosets and which are parallel to H, right? So the cosets of H, they consist of partition of three-dimensional space. Now why? Because whole of the three-dimensional space is represented by all such planes which passes through different points and which are parallel to H, and moreover each one of them is a distinct plane, right? Different planes do not have the same elements, same points within them. So that is why it forms a partition of the group G into different planes, correct? So this is one such example. For the next example, let's consider the group of matrices. So we know the general linear group having order 2 whose elements are taken from the set of real numbers. So it has all 2 cross 2 matrices where the entries are taken from the set of real numbers such that the determinant of the matrix is non-zero, correct? This is our group. Now let's consider the special linear group having order 2 and whose entries are all real numbers. So this is our subgroup. So it consists of all 2 cross 2 matrices such that the entries are taken from the set of real numbers. But now this the determinant AD minus BC is exactly equal to 1. So all such matrices whose determinant is exactly equal to 1. So obviously this is a subgroup of this group G. Here the group operation is matrix multiplication. Now what we do, in order to create a coset, we need a coset representative. So let's select it from the group G. So group G, if we are selecting it from group G, it would be a matrix which is a 2 cross 2 matrix and it would have a non-zero determinant, correct? Now using this we can create a coset which we are calling by AH. So this coset would consist of the set of all 2 cross 2 matrices with the same determinant. How this is there? Let's suppose we have selected A as this one, 2 0 0 1. So what is the determinant of this A? The determinant here is equal to 2. So therefore, because H contains all the matrices which have determinant 1, so if you multiply this A with H, with any member of H, you would again get a 2 cross 2 matrix. Now whose determinant would be equal to, suppose this sum is M. So M is equal to A into some element from H, So here the determinant of m would be equal to the determinant of a into the determinant of h. Determinant of a is 2, determinant of h is 1, so the determinant of m, the product, is 2. So here in this coset which is generated by taking a as this particular matrix, would have the determinant as equal to 2 for each of the elements present within it. Similarly, if we take a as this matrix, the determinant of this matrix is -3. You can clearly see that. So for this coset, this one, it would have all the elements which are 2 cross 2 matrices, such that the determinant of each one of them is equal to -3, right? So this is how you can have different cosets which partition the groups into different partitions. So I hope you understood these examples well. Well, that is it for this video. Thank you for watching.